A steam at 100 degrees centigrade is passed into 1.1 kg of water contained in a calorimeter of water equivalent 0.02 kg at 50 degrees centigrade till the temperature of the calorimeter and its content rises to 80 degrees centigrade. The mass of the steam condensed in kg is. So this question is based on the, you can say, we can use principle of conservation of energy. So it means the heat gained by the water and the calorimeter will be equal to the heat lost by the steam during the, you can say, condensation and cooling, which is supposed to happen at the temperature of 80 degrees centigrade. We start from there only. We say the principle of conservation of energy and which gives us that heat gained by the water and the calorimeter by the water and calorimeter will be equal to heat lost by the steam during condensation and cooling at 80 degrees centigrade. So let us solve it for the heat gained by the water and calorimeter. Heat gained by the water and calorimeter and this can be, we can write directly based on the formula. Let us suppose that is given as Q with respect to water plus calorimeter will be equal to mW, that is the mass of water, and Wc, which is a water equivalent of the calorimeter, multiplied by specific heat, temperature final minus temperature initial. So here mW is our mass of water, Wc is water equivalent of calorimeter, C is our specific heat, Tf is the final temperature, and Ti is the initial temperature. So we know all the values, we simply substitute it. So we get Q for water plus calorimeter 1.1 plus 0.02 and we have 4200 multiplied by 80 multiplied by 80 minus initial temperature is 15 degrees centigrade, and this gives us 1.12 multiplied by 4200 and multiply by 65, and this comes to 305 and 760 joules. Now we are going to find out heat released by the steam, lost by the steam. Heat lost, or we can say released by steam. And the heat released, or you can say lost by the steam, it is a two-step process. We can say when steam condenses, it releases energy in two stages. It releases energy in two stages. Stage 1, which is called as a latent heat of condensation. Latent heat of condensation. Let us represent it by L. So we can not L but QL. Q condensation will be equal to M S multiplied by L, where Ms is the mass of condensed steam which we are supposed to find out. Ms is mass of condensed steam, and L is the latent heat of condensation for the steam. L is the latent heat of condensation for steam. And second is the cooling of condensation. Stage 2. Is our cooling of condensed water from 100 degrees centigrade to 0 degrees centigrade. Cooling of condensed water from 100 degrees centigrade to 0 degrees centigrade, and we can call that as Q, cool, which will be equal to Ms multiplied by C and multiplied by 100 minus final temperature. Therefore, we can write that total heat released by steam, let us call that as Q steam, and this Q steam will be now equal to we have two equations. Q condensation and Q cool. Q condensation plus Q cool. Now we simply substitute the you can say formula, the equations rather. So we get this as Q condensation was our ms multiplied by L plus we have ms multiplied by C, and here we have 100 minus Tf. ms we can take as common, so we get ms, we have L plus C multiplied by 100, and this is our 80. Now we substitute other parameters also, and Q steam we get will be equal to, we have this as ms, latent is given 2.26 into 10 to the power 6 plus 4200, and this comes as 20. So we get Q steam will be equal to ms multiplied by 2.344 10 to the power 6 joules. Now we can use conservation of energy like we stated earlier in the first paragraph. So we can say conservation of energy, we get Q water plus calorimeter is equal to Q steam. Now we simply substitute the values. We get this as 305,760 is equal to ms multiplied by 2.34 into 10 to the power 6. So therefore our ms is approximately equal to 0.13 kg, which we were supposed to find out. So the option that are given to us, option number A is the correct option. You can say option A is correct. A is correct. So this completes the question. Thank you.